Sir, may I come in, sir?
Please.
Good morning, sir. Good morning, sir.
Good morning.
Thank you, sir.
Please take your seat.
Thank you, sir.
Abhishek,
Yes, sir.
you are from Gaya and studied in Ranchi. Matlab, basically, B.Singh Sindri.
Yeah, BIT Sindri is in Sindri, sir, Dhanbad.
Can you remove your mask?
Yes, sir.
So, you tell us major industry or mineral based or different industry in Jharkhand. Name.
So in Jharkhand, we have lot of coal deposits, which is a major mineral resources.
Okay.
Apart from that, in Jamshedpur, we have steel industry, Tata Steel.
Where is the iron ore coming from?
So we also have iron ore in Jharkhand.
Which area?
So the entire Chota Nagpur Plateau area being a plateau area, it has a lot of iron reserves.
What other mineral resources there?
So we also have aluminium ore, bauxite.
Or?
So manganese ore.
Manganese कहाँ पर है?
I don't know about the specific location in Jharkhand.
Okay, चलो. Vinoba Bhave कौन थे? Who was he?
Sir, he was very active in the Indian freedom movement. He is also known as the spiritual successor of Mahatma Gandhi, and he is very famous for his Bhudan and Gramdan movement. He was also awarded the prestigious Bharat Ratna Award.
So Bhudan, he was involved. Okay. Sure. You are already working in the Bihar Power Distribution Company.
Yes, sir.
So is it a loss-making company or?
Yes, sir. Discoms are loss-making.
Why?
So because of several reasons. One of them is that the AT&C loss of all the Discoms are very high.
No, it is high, but why it is high?
So one reason is that the billing and collection efficiency is low.
Billing and collection efficiency is low.
So that is why revenue cannot be realized.
Okay.
Plus, a lot of electricity theft is there.
Theft is there.
And lot of technical losses which involve, because the infrastructure is very old, it is not augmented, hence we have a lot of distribution losses.
True. But so many infusion has happened, APDRP,
yes,
several programs happened.
Yes, sir. So the major loss...
Even then they remain like this.
So the major loss today is the commercial losses, which involve, as I said, billing and collection efficiency is low, electricity theft is high, and also the tariff is not reflective of the cost which Discoms has to bear. Because of the populist nature of and the welfare nature of the electricity, the tariffs are not reflective of the cost.
So basically there is a politics which basically tariff.
So that is also one
regulatory and all those things are happening. ठीक है, okay.
What do you mean by signal?
So the signal is something, it's a function, mathematical function, which depend on one or more variables.
So any mathematical function can be said as signal, which depends on more than one variable.
So one or more than one variable, that's the definition.
Y is equal to x cube, it is a signal.
Yes, sir.
Okay, so where do you use this signal x cube? If it is a signal, it may have been used somewhere.
So we do study that in maths, but that is not so common because that is not found in physical systems.
What are physical systems?
So like a speech signal is one of the example of physical signal.
Okay. A speech signal, we want to convert it into electricity.
Yes, sir.
How can we convert?
So we can use transducer.
What kind of transducer is useful for this purpose? There are several transducer, right?
Yes, sir.
So हम RTD तो नहीं use कर सकते. ठीक है. We have to convert speech into electricity.
Yes, sir.
So suggest some method.
Sorry, sir, I could not recall.
Okay, no issue, no issue. Why we are wanting to convert speech into electricity? Why not directly processing speech?
So because it is easier to process electrical signals, that is why we convert it into electrical signal. Plus there are a lot of other advantages as well. That is, we can have frictionless electrical devices, so the losses are less, attenuation is less. All those benefits we have with electrical signals.
Good. Attenuation लेस रखने के लिए सिस्टम में क्या करेक्टर डिजाइन करते वक्त आप ध्यान रखेंगे?
So the interference due to noise should be minimum.
In electrical devices, how interference with the noise can be minimized? Suppose machine you are designing.
Yes, sir.
Any machine. What you do to reduce the interference of noise?
So we can use devices with high CMRR.
High CMRR. That will be true for electronic devices. चलो खैर वही बात करते हैं. CMRR high है. It means noise interference would be less.
Yes.
So ideally, what should be the value of CMRR?
It should be infinite, sir.
Infinite. Let us suppose CMRR is very low.
Yes, sir.
Then what impact will take place?
So the common mode signal will be amplified, and that will distort the output. Noise is an example of common mode signal, so the interference due to noise will be maximum in that case.
What do you mean by distortion in signal?
So distortion in signal is any unwanted element in the signal.
Okay. So आने दो unwanted element, इससे क्या फर्क पड़ेगा सिग्नल पर? जैसे आपको आना है, आपके साथ कोई एक अलग आदमी भी आ जाएगा, क्या फर्क पड़ेगा? आप तो आ ही गए ना?
Yeah, sir, but it will impact the quality of the signal.
It will impact the quality of signal. Good. Audio frequency range कितनी होती है?
So 20 hertz to 20 kilohertz.
Okay. Radio?
Sir, in megahertz.
How much? Megahertz to 1000 megahertz, 2000 megahertz.
Sir, till 100 megahertz.
Yes. Power frequencies कितनी होती हैं?
Sir, we use 50 hertz. In many countries, 60 hertz is also used.
Up to what frequency range we can say it is power frequency?
100 hertz we can say.
100 hertz. ठीक है. Power frequencies पर transformer बनाने के लिए what would be the core material?
So it should be ferromagnetic core.
Good.
It should have.
And at radio frequency, what can be the core material?
Sorry, sir.
Same material we can use or not?
Yes, sir. We can use the.
Your answer is correct. At power frequency, we use ferromagnetic.
Yes, sir.
Now I'm moving to radio frequency. So can we use this material?
I think, sir, we need ferromagnetic material to establish the flux in the core. That's the basic of transformer. But
Okay.
we'll also take care of the high eddy current loss and hysteresis loss that might occur at that high frequency.
Eddy current loss and frequency are related how?
So eddy current loss is proportional to square of frequency.
At low frequencies, we do laminations.
Yes,
Laminated cores we use. What do you mean by laminated core?
So the core is not one solid piece. Rather, it is made up of laminations which are riveted tightly with nut bolt. It basically does not provide path for the eddy currents to flow and hence reduce.
Don't you feel that there would be a gap between two cores? One plate and another plate. There would
Yes,
be a small air gap.
So the laminations are very thin and it is stacked very tightly against each other to minimize that gap.
So obviously कितना भी आप थिक कर लो, air तो हो ही जाएगी ना. How can you remove that air? Oil का नाम सुना?
Yes, sir.
Does the cores are immersed in oil या दोनों different होते हैं?
Yes, sir. Oil is it is immersed in the oil. It provides insulation.
Good. Cheers.
Thank you, sir.
Abhishek,
Yes, sir.
you are in power sector.
Yes, sir.
Okay. What is the nature of work at your job place?
So my job profile involves supervision of a project, reconductoring project, which is a very ambitious project of the state government.
Okay. What do you do in that one?
So in reconductoring project, the profile involves replacing of all existing dilapidated conductors with augmented conductors, higher capacity conductors, and in LT line we replace the conductors with AB cables.
Okay. Can you explain about the solar cell?
Yes, sir. Solar cell is a PN junction where when we irradiate that with solar energy, lot of electron hole pairs are generated and that creates a potential difference.
Okay. To know the performance of the transformer, which type of tests are conducted?
So we basically conduct 3 tests. First is the polarity test, second is the open circuit and short circuit test, third
Any
is
other?
the maximum heat run test.
Any other?
Uh,
Generally, the tests are available in the textbooks also.
yes,
But
sir.
in the practical, you conduct so many other tests also.
So we can also conduct dielectric tests.
Any other?
Sorry, sir, I could not recall right now.
To know about the noise, will they conduct any test? To know about the harmonics, will they conduct any test?
So I do not know, sir.
Okay, no problem. In case of the power transformer, which type of the core is preferred?
Sir, we use ferromagnetic core. Sir,
Sure.
as in which type, sir?
In case of the power transformer, which type of the magnetic core is selected?
Sir, could you please elaborate it like?
Which type of the core? We use it, so many materials are there, na? Silicon steel, so many other materials are there. Na?
Yes, sir.
In case of the power transformer, which material they are using for core?
So we use silicon steel, sir.
Silicon steel.
Yes, sir.
Then what about distribution transformer?
Sir, the same core.
Core is same in both cases.
Sir,
Okay, no problem. Why this LED bulb is a more efficient when compared to tube light?
sir, it consumes less energy.
Why? Reason?
So being in electronic devices, the current required is very less, whereas in tube light we need high starting current, and inductor also is present there.
Any other reason? Okay. Did you hear about this gas insulated substation?
Yes, sir.
What is the advantage of this one?
So GIS is used where we have very less space. It is very compact.
Okay.
That's the main advantage of GIS.
Any disadvantage?
So it is costly.
Okay.
Plus we are using SF6 gas, which will cost us. In air insulated substation, air is free.
Okay. What is the difference between the synchronous condenser and static capacitor?
So in synchronous condenser, by varying the field current, excitation, EMF, we can get smooth variation of reactive power output.
Okay.
But in static capacitor, we can only get fixed value of Q, output Q.
Okay. Suppose you have one conventional synchronous motor and synchronous condenser.
Yes, sir.
How can you identify which one is a synchronous motor and which one is synchronous condenser?
The synchronous condenser main purpose is to supply Q, reactive volt ampere. So there is no shaft there because it is not used to run a mechanical load. Whereas in normal synchronous motor, there will be a shaft length.
Okay. What is the doubling effect?
So then doubling effect is in power transformer due to magnetic inrush current. The flux at the starting is very, very high. It is more than twice the normal value of the flux. That is known as doubling effect.
Okay. And last question, you are getting handsome salary and you are in electrical department only. Then
Yes,
why
sir.
do you want to leave this job?
Sir, I'm very happy with my present job, but at the same, I'm very happy with my present job because it gives me the opportunity to work in the core sector. At the same time, I can interact with the people. But I do realize that the scope of my work is very limited. It is only limited to distribution sector. Whereas if I get my first preference, which is CPS Group A, I will not be able to work in distribution sector, but also generation sector, transmission sector, renewable energy sector. And I think I will get more job satisfaction and I will be happier in the long run.
Same answer everyone is giving from morning. I am very satisfied with my job, and whatever you have said, each and everything is said by every person. So are you taking coaching from same person? Everyone is taking classes from same person?
No, sir. I think my reason might be unique. I mean, I'm working in a distribution company, which is a core sector company, no doubt.
So my question is, did you have taken help from any coaching? Have you been coached by any person to get up to this answer?
No, sir. This I framed it by myself. I prepared this, but I've done it by my own thinking and what I really feel about my present job and what I want from my next job.
Okay. But in every job, there is a limitation.
Yes,
There is a
sir,
limitation.
but I feel
As
that
per your expectation, you may not be getting. There will be some limitations. Okay. Abhishek,
yes, sir.
what is the charge of a P-type semiconductor?
Sir, what's the word?
Charge.
Of it is neutral, sir.
Can you justify how it is neutral?
So for every holes we have, we also have the negative ions. So the overall neutrality is there.
Neutrality will be compared with respect to holes and electrons, or electrons and something else.
So the overall charge should be 0, sir.
Zero. How to justify as an engineer, as a science student?
The net positive charge should be equal to the net negative charge in PN. In any p-type semiconductor or any semiconductor material.
Okay. What is clipper circuit? What is clamper circuit?
So a clipper circuit is a diode circuit which clips the input signal, as in it will cut the input signal. Whereas in clamper circuit, it adds or subtracts a DC component.
Good. Which device is converting audio signal to electrical signal?
So
Which instrument or transducer, whatever the name you want to give?
A transducer, sir. I do not know the specific name.
Which is converting audio signal to electric signal. And vice versa.
So we are using this mic which also converts speech signal to electrical signal.
Right, you are right.
Yes.
Which is converting electric signal to audio signal.
So the
Microphone, you said
the
right.
boxes we use, sound boxes.
Speaker.
Speaker, yes.
Okay. How to decide maximum clock frequency of a synchronous counter? Synchronous counter का maximum clock frequency कैसा decide करना?
So two things. One is the propagation delay of the individual flip-flop and the number of stages we are using. That too will decide the maximum
Synchronous
frequency.
counter में clock पूरा flip-flops के लिए common रहते अलग रहते?
In synchronous counter, clock is common.
Then what is the answer? Can you revise your answer?
Yes, sir. The F maximum is equal to 1 by n into TPD. I think in synchronous counter.
In the ripple counter then, what is the answer?
Sorry, sir. That is in ripple counter. But it depends on n and it depends on the propagation delay of individual flip-flop.
For synchronous also?
Yes, sir. To some extent, the formula. No, sir. The n is. Sir, I'm not remembering that.
No issue, no issue. You know gray code?
Yes, sir.
Where we are having the usage of this gray code?
So gray code is a minimum change code and it can be used in computer memory system because from going from one memory level to the next memory level, only one bit changes. So this saves a lot of computer power requirement.
Is it?
So this is one application of gray code which I have read, sir.
Anything a part of this?
Gray code is also used in this K-map formation.
So gray code use करके K-map develop हुआ. K-map में gray code का sequence है क्या?
The K-map में we have gray code sequence.
कुछ और stepper motor आपको मालूम होगा?
Yes, sir.
Any relation with a stepper motor and a gray code?
Sorry, sir, I do not know this.
Okay. What is the transfer function?
So transfer function is the ratio. Transfer function of an LTI system is the ratio of the Laplace transform of the output response to the Laplace transform of the input.
Okay.
With initial condition assumed to be 0.
What is impulse response?
The output of any transfer, the output of any system when we give impulse function as the input is the impulse response of that system.
Last question. What is noise margin? Noise margin. Logic family is related.
Yes, sir. Sir, I do not know that.
Okay, sir.
Main rivers in Jharkhand?
Sir, we have Swanrekha River. Swanrekha River. That is the main.
That's
river.
all.
Sir,
एक ही river है.
Sir, Damodar River is also there.
और
So that too I remember.
which project has been installed, which is multi-purpose
So
project?
Damodar Valley Corporation, DVC.
Installed. Installed मतलब बहुत दिनों से रुका हुआ है, but it is
Installed, sir. If this fertilizer plant in Sindri Sir, in water.
एनीवे मैं पावर से रिलेटेड पूछ रहा था, पावर एंड इरिगेशन मल्टीपर्पस। एनीवे
Sir, in Jharkhand. Sir.
झारखंड, आई एम टॉकिंग ऑफ झारखंड। ठीक,
Sorry, sir.
ओके। व्हेन इज योर इंटरव्यू अभिषेक?
Sir, 9th of March.
9th March। ठीक है, आई थिंक विल क्लोज योर इंटरव्यू, विल कॉल यू फॉर द फीडबैक। ओके,
Thank you, sir. Thank you, sir.
Yeah, please take your seat, Abhishek. Abhishek, you are from the Jharkhand and Bihar both. So basically, both these state, अब इनके legacy भी हैं, तो इनके बारे में थोड़ा सा पढ़ लीजिएगा।
Okay, sir. I prepared Bihar, sir. I'll prepare Jharkhand.
हाँ, so you prepared about both because you have studied more
Jharkhand,
from
yes.
Jharkhand and you are working in Jharkhand, so
So I'm working in Bihar.
हाँ, बिहार, हाँ, ओके। तो ये दोनों थोड़ा सा कर लीजिएगा, ओके। दूसरा ये है कि बिहार का चक्कर, मतलब बेसिकली आपका डिस्ट्रीब्यूशन नहीं है, जनरेशन तो है नहीं,
Yes.
ओके। सो वहाँ का जो इशू है वो थोड़ा सा यूनिक है, तो उसके क्या आंसर्स होंगे? यू गिव रीजनेबली गुड आंसर, बट दी जनरल नेशनल लेवल पावर रिफॉर्म्स एंड पावर थिंग एंड ऑल्सो डिजिटल इंडिया, ये सब आप थोड़ा पढ़ लीजिएगा। सो बेसिकली अपडेट अबाउट एनर्जी sources, new and renewable sources of energy, what is our commitment, how much we have progressed solar में या कहीं में। फिर रेलवे में क्या हो रहा है, कितना कुछ हो रहा है, आपके फादर रेलवे में है।
Yes.
तो ये सब थोड़ा सा आपसे काफ़ी एक्सपेक्ट किया जाएगा कि आप बताएं, वी आर ऑलरेडी वर्किंग। इनिशियली आपका थोड़ा कॉन्फिडेंस लो था, यू वर क्वाइट अप्रीहेंसिव, बीच में आप थोड़ा समझ गए, तो गो विथ फुल, यू आर ऑलरेडी इन जॉब, सो गो विथ फुल कॉन्फिडेंस। दूसरा ये है कि कॉन्फिडेंस तो ठीक है, लेकिन गेस वर्क बहुत ज़्यादा नहीं होना चाहिए।
Okay, sir.
तो हर क्वेश्चन को का जवाब देना ज़रूरी नहीं है, ठीक है। आपको नहीं आता है या डाउट है तो इट्स बेटर टू से कि साहब हमको बहुत ज़्यादा इसका आइडिया नहीं है। यदि वो बोलेंगे फिर भी आप अटेम्प्ट करो, तब अलग बात है, तब दैट इज़ योर बेनिफिट। सो अभी तो हम आपको 116 दे रहे हैं, लेकिन आप 126 125 आसानी से ला सकते हैं, 130 तक आप आराम से ला सकते हैं, लेकिन आपको वर्क करना पड़ेगा बिकॉज यू आर स्टिल हैविंग 10 days और 12 days, तो ये सब थोड़ा पढ़ लीजिए।
कितना मार्क्स थे लास्ट टाइम?
130, sir.
130?
हाँ,
आज तो नहीं लग रहा यार 130
130
क्या हुआ, मतलब आज क्यों ऐसा कुछ? आज या तो सिग्नल शुरू हो गया उसमें, अंडर कॉन्फिडेंस में लगा यही कि स्टार्टिंग सिग्नल, वो जानबूझ के सिग्नल से स्टार्टिंग की गई, क्योंकि लास्ट टाइम मुझे लगता है कि संटिंग वंटिंग से शुरू हुआ था, तो कुछ मेरे दिमाग में था कि पहले इलेक्ट्रिकल से शुरू हुआ है, लेट्स अनकंफर्टेबल डोमेन से शुरू, और उस ट्रैप में आप फंसते दिखे, क्योंकि जितनी देर मुझसे डिस्कशन था बहुत अंडर कॉन्फिडेंस दिखे, तो मेरा ऑब्जर्वेशन यही गया सर के लिए। तो वहाँ भी हो सकता है, कई बार हो सकता है कंट्रोल से शुरू हो जाए, डिजिटल शुरू हो जाए, तो एकदम गिव अप नहीं कर देना। बहुत अच्छे कैंडिडेट हो, बहुत अच्छा नंबर ला सकते हो, बैलेंस पर्सनालिटी हो, ठीक है, बट अनकंफर्टेबल डोमेन में एकदम गिव अप करने लगते हो, और कई बार फिर बहुत ब्लाइंड गेस, काउंटर तो मतलब क्या ही कर रहे थे आप ठीक है, तो डोंट गो फॉर द ब्लाइंड गेस। हाँ, थोड़ा रिवाइज कर लो, बेसिक रिवाइज कर लो, या अगर नहीं आता है, जैसे काउंटर वाले में आपको पता था कि आप नहीं कर रहे हो, फिर भी आप इफोर्ट कर रहे थे कि शायद मेरा सही हो जाए, उससे अच्छा है कि कह दो नहीं आता है।
Okay. Abhishek, you are in power sector now.
Yes, sir.
Get some information regarding this Bihar. What is the approximate load demand? How many generating stations? What are the new projects are going on? इसके बारे में थोड़ा जानकारी कर लो. And as well as your father in railways ना, then what type of voltage rating and which type of motors they are using, and regarding the bullet trains बारे में थोड़ा जानकारी कर लो. Especially practical system part of.
Dear Abhishek,
Yes, sir.
So when we are talking about the p-type semiconductor charge, after learning semiconductors, you should not forget our basics atomic structure. The charge on any material will be compared with the, not with holes, electrons and protons. Electron is negative charge, proton equally positive charge. So whenever you are talking, any question is related to the charge, comparison is between the electrons, number of electrons and number of protons, not with holes. Generally, it is a common answer from most of the students after learning semiconductors. भूल जाते हैं, है ना? Got the point?
Yes, sir.
And see, transducers you have to learn. थोड़ा अच्छा बताया, मगर थोड़ा अच्छा learn. Measurements is a part, almost is a core for you. And cutoff frequency आप तो already बताया. Ripple counter के लिए, when a question is for synchronous, सब लोग, not only you, other people also giving same answer. Ripple counter के लिए maximum clock frequency how to calculate, you know. Synchronous के लिए क्यों नहीं पढ़ना? It is simply 1 upon propagation delay of the flip-flop.
Yes, sir.
Okay? And थोड़ा डिजिटल में थोड़ा ब्रशअप करो. लॉजिक फैमिलीज का भी नाइस मार्जिन दिस.
आप थोड़ा ब्रशअप कर लीजिए न्यू इवेंट्स.
कैन डू वेल.
ओके
Okay, sir.
और लास्ट ईयर आपको अच्छे मार्क्स मिले हैं तो
नहीं, आप रिपीट करोगे वो उस मार्क्स को, ऐसा नहीं है. आप रिपीट थोड़ा छोटी छोटी बातों पर काम कर लो तो यू विल रिपीट दैट मार्क्स.
When you say interview,
इतने अच्छे नंबर पा करके भी कैसे बाहर रह गए, क्या हुआ?
मेंस में कम था सर.
अच्छा, मींस इस बार ठीक है.
पेपर 2 का सर पता नहीं चलता है सर कितना आएगा. पिछले बार भी लग रहा था कि आ जाएगा, बट पेपर 2 में बहुत कम हो गया था, तो बाकी सब में अच्छा.
कहाँ चूक जाते हो पेपर 2 में?
पेपर 2 में से सिली मिस्टेक हो गया था पिछले बार, तो काफी पावर सिस्टम के क्वेश्चंस.
पावर सिस्टम लेंदी क्वेश्चन हो जाते हैं कई बार.
जी सर.
चल, होप फॉर द बेस्ट.
ओके
अब आपका इंटरव्यू
सर 9th.
enough time.
थैंक यू सर.
ओके.